Okay. Thanks everybody for coming out to our event tonight. Like the title says, we're going to be having Dr. John Olds. I'll introduce him in a second. First, we're going to go through the events that we have coming up. Next week is the first wellness day of the semester. So next Tuesday, I should say. So we won't be having our Tuesday meeting. Instead, the next meeting will be the 16th, which we have Dr. Robert Lindbergh from the AIAA Planetary Protection Committee. So that should be a pretty cool presentation. So yeah, that's our next event. And the QR code is up there for attendance. And also Josh just put the link in the chat. So be sure and fill that out. And then tonight we have an NC State MAE alumni and actually an NC State MAE Hall of Famer, Dr. John Olds, who's speaking. He's the CEO of SpaceWorks Enterprises, which includes Generation Orbit. So without further ado, the floor is yours.
Okay, good evening, everybody. I'm going to share PowerPoint screen and see if you can tell me if you can see it. Does that look good?
Yep.
Okay, great. So I'm happy to be here. Good to see all of the my fellow Wolfpackers out there tonight. I have about 30 or 35 minutes worth of content that I want to share with you, some PowerPoint updates on what we're doing here in Atlanta at SpaceWorks and Generation Orbit. And I have a couple of videos that I'm going to share. And then I hope there's some questions at the end, and we can treat this. You can ask questions along the way, but I've reserved some time at the end, so I'll stay as long as you need me to stay to answer questions. As Brian said, this is a little bit about me. I'm coming to you today from my office in Atlanta, just north of Atlanta. So I'm the founder and CEO of an organization called SpaceWorks Enterprises. And I have about 30 years of experience in the aerospace industry. I've worked at General Dynamics. I worked there in Huntsville in the Advanced Concepts Group. I was a visiting assistant professor at NC State for a couple of years. So had an office in Broughton Hall, which you guys won't remember as being an MAE building, I'm sure, but it was. And over on the Centennial campus too, I had an office there. I was part of the Mars Mission Research Center. And then I moved here to Atlanta. I was on the faculty at Georgia Tech in the School of Aerospace Engineering for about 11 years. And I grew up in South Carolina. I did go to NC State for undergraduate as well as my PhD. And so I was in the Aerospace Engineering School. In those days, aerospace and mechanical were not quite as integrated as they are today. They were in the same department, but they operated a little independently. I have good memories of my time there as an undergraduate. I was the chairman for a couple of years of the AIAA student chapter there. So I did that. We used to meet in Truett Auditorium in the evenings, and trains would go by and rattle the speakers, and we'd have to stop talking for about a minute or two when a train went by right outside that window there in Broughton. You guys had a much more modern attendance sheet. When I was there, the professors, particularly the performance professors, 260, MAE 261, and the senior design professors would have sheets in the back, and you'd have to sign your name that you attended the AIAA meeting. And you could do something like drop a homework assignment, or I don't know if you guys do that anymore, but they used to incentivize us to come to these meetings. We had a lot of people, like, 60 or 70 aerospace engineering students in the evening would come because Professor Hassan or Professor Perkins or somebody like that, Professor Silverberg, would sign everybody up, and you get something for coming to the AIAA meeting. So I was there. We were talking about basketball before. I was there. I started at NC State the year after we won that national championship. So I was there during the early Jim Valvano days, and so a good time. A lot of stuff in Reynolds back then, of course. I went out to Stanford, got my master's degree, worked for a couple of years, came back and got my PhD at NC State. Brian said I'm in the Alumni Hall of Fame. That's a nice honor for me. I appreciate it very much from the school. and I'm currently a member of the MAE Advisory Board there at NC State. I'm going to talk to you a little bit about my organization here. We have about 65 or 70 people here in Atlanta that work for SpaceWorks Enterprises. I'll give you a little bit of an introduction to the organization, and I want to spend a lot of time talking about what we're doing in the area of hypersonics. I'm going to use some subsidiary names along the way. So we have some wholly owned subsidiary organizations. Generation Orbit is the one that is associated with our hypersonics work. So if you go to generationorbit.com, that's one of our organizations. So it's under our umbrella, and a couple of others. And I've got one son. We live here in Dunwoody, Georgia, just a suburb of Atlanta. All right. So let me start. Before I do much, so I've got all our little videos on the right of my screen. Can you guys see on your screens? Can you see all the way to the right, or do you have a white box on top of this area to the right? Can you see the whole screen?
Yeah, we can see like the whole presentation, nothing else.
Great. Okay, so what is SpaceWorks Enterprises? And I mentioned that I founded this company back in 2000. My wife and I started in kind of a garage and at our house, and then we had a small couple of offices in North Atlanta, and we've grown from that point, kind of an organic growth, gotten bigger and bigger. And so this is a little bit of our team. This is back pre-COVID. A lot of the pictures I'm going to show you later on coming up in this presentation has people with masks because of COVID, but this picture was taken at one of our company picnics the year before COVID, so that would have been 2019. And so we're aerospace enthusiasts, and we have a lot of interest across the spectrum of aerospace, from satellites to flight, hypersonics, high-speed propulsion, advanced concepts, human exploration of space, planetary defense. I'll talk to you about a little of those inspirations. But we believe as aerospace professionals, people that are operating in aerospace engineering, that we are called to make a difference. We're trained in a skill set that I think can make a big difference in the world, for our nation, for the planet, for our overall economy, global economy, and for the species. And we like to tackle hard problems. We like to tackle hard and important problems. So for the country, one of our main focuses is in hypersonics. So we believe that hypersonics is the next frontier. I'm going to spend a little bit more time, I guess, tonight talking about hypersonics, so I won't dwell on it here. But not only is it important for national defense, we believe it's important for global connectivity, shrinking the globe, making it more accessible to people to travel around the world. For the planet, as aerospace engineers or aerospace professionals, I think we have an obligation to solve some of the hard problems, specifically related to energy, clean energy, climate change, orbital debris removal, even protection against planetary impactors. So our company has spent some time on each of these: space-based solar power, for example, for energy and climate change control, ways to clean up orbital debris, and planetary impactors. In this context, I mean as meteoroids or asteroids, being able to protect against that. So some of the great kind of existential threats that we face, I think aerospace professionals have a role in solving those. For the economy, you all more, and I have too, we have witnessed really a revolution in space, because the government-driven investments in space have given way to a lot of private capital. And you guys live in the era of SpaceX and Blue Origin and Virgin Galactic as being primary, large players in the space economy. That's driven by private investment, at least a lot of it is. And so there's been a revolution there. And I think that that we have an obligation to try to bring the moon and cislunar space into our economic sphere, opening up to private tourism, to private space flight, to economic development, resource utilization. All of those things I think are important to bring that into the economy as we expand into space. And then finally, for the species, honestly, I think aerospace people are going to lead the way in the survival of our species, getting us off of the planet, exploring the rest of the solar system and expanding beyond. And our company typically believes in colonization, having humans live, work, and play in space as part of the long-term survival of our species. We have technologies we're working on there, as I've spoken about in the past, like human stasis or human torpor, being able to put people in a sense of therapeutic hypothermia and having them go out into the solar system in sort of a sense of hibernation. So those are some of the technologies we're exploring. So we're after big things, and we have a number of brands. If you can see this slide, a number of brands that we operate under, and I'm going to concentrate primarily on this top center one here tonight. But if you follow us on LinkedIn and see what we're up to, we are doing reentry capsules. We did a great drop test campaign, and we're moving that to high altitude drop test for sample return capsules. That's an area we're investing in. We've released some new aerospace software related to trajectory optimization in the top right. Advanced design work, we're working on global commercial flight, point-to-point flight, terrestrial flight, economic models, space launch. We're looking at reusable systems, human space flight. I mentioned the torpor activity. In space assembly, we're doing a project for constructing large space structures in space, along with our partners at the Air Force and at NASA Langley. Small satellites, we launched our first small satellite payload a couple of years back, so it's in low Earth orbit currently. That's the first launch we've had there. And then we do a lot of market forecasting, so we look at what's next. So again, as a small company, we do a lot of things, but I'm going to concentrate on hypersonics here tonight. A little bit about where we are. I don't know if any of you are from Georgia or from the Atlanta area, but we're in Atlanta, so we're just north of Atlanta. So I've got two locations here. One is more of a headquarters type of building. So we're on the 14th floor of this building on the left. That's where I am right now. And then we have more of a manufacturing R&D facility over in Doraville, and it looks like that picture on the left. So more of a low type of building. Again, we're about at 65 or 70 people. A good percentage of our staff are engineers, and a good percentage of those are aerospace engineers. Okay, got one more little thing to show before I get really started, and that is our heritage flight projects. We had got into this probably about 10 years ago, where we started doing small scale flight demonstrations, ranging across the top from UAV demonstrations, high altitude balloon demonstrations. You can see our first mission to the International Space Station with an astronaut there in that picture behind one of our reentry capsules. And then more recently, we flew on a PSLV out of India. We flew a hosted payload for Internet of Things connectivity, so ground to space communications. Across the bottom is our generation orbit activities. That's what I'm going to spend more time on today. And that's the hypersonic investment. So we've done a number of captive flight tests, thruster development tests, two ground hot fire tests of our X-60A system. All right, so I want to introduce you to the family here of the X-60. The X-60 started life as, I'll go ahead and flip to that, started life as what we call the GO launcher. So generation orbit starts with a G and an O. We pronounce that GO, even though it's two capital letters, we'll pronounce it as GO. And our systems were called GO launcher. And we started that back in 2011, 2012 as a space launch activity. We initially started to compete in the area of small CubeSat launch. If you're following the industry now, there are a lot of companies that are doing that. We got up to probably 30 or 40 companies that were investing in small satellite launch. And some of them have emerged and are quite successful. I'll point to like Rocket Lab as one of the more successful small satellite companies. Virgin Orbit, my mistake, Virgin Orbit, just completed their first demonstration of Launcher 1 to orbit. And Firefly is close, Astra is close, but there are a number of them, not only in the United States, but in Europe and Asia as well. And so we pivoted as an organization to pursue hypersonics. And the first one, and the one I'm going to show you the most about, is over here on the left, called the X-60A. The A is our little one. It's our first one. It's about 3,000 pounds gross weight, payloads around 150 pounds or so to hypersonic test conditions. These are R&D vehicles. They're designed as flying research wind tunnels. Facilities are in high demand in hypersonic testing, and it's hard sometimes to get to the conditions you want to test at for aerodynamics or aerothermodynamics for long periods of time unless you're actually flying, and that data is more relevant to the researchers anyway. So that's our first one, X-60A. We've branched out into 2 additional activities that are derived from that. The X-60C is a larger version, much larger version, maybe 5 times as big, designed to fly faster and carry heavier payloads, multi-engine, with a recoverable section. The X-60B here on the bottom is a version that is actually smaller that we're pursuing as a target application, X-60B. And then last one on this chart is the Go Next, which is our vision vehicle. Vision vehicle is kind of, where do you want to go? And that one is a combined cycle propulsion ejector ramjet vehicle designed for long range, fully reusable, horizontal takeoff, horizontal landing. So that's our ultimate vision. Where we're spending most of our time is on the left of this chart, and we're about to start real close, really, to starting work on the middle 2. So this is the family. This came about, just interesting story. Like I said, we call them the Go launchers originally, and our sponsor at the Air Force here for the first one said, you know, this has the makings of an X-plane. It's a research vehicle, and so maybe we ought to put in a request to make it an X-plane. And the Pentagon decided to give us that designation about 3 years ago. So we changed from Go Launcher 1 to X-60, but we kind of like it because the 60 and the 0 there, the 6 and the 0, kind of, if you squint, look like a G and an O, sort of. So we think it's GO, so it's got our letters in there. So we kind of like the X-60 designation, and then the letter at the end is just the variant that we've got. So we're like, you know, really on Wikipedia, and really, you know, an X-plane now, and so that is fun to work on an X-plane, to think that you're working on that. Talk about the X-60A, and I've got some pictures of where it stands. This is just my chance to talk about what it does. The X-60A is our first one, the small one of the family. It's designed to reach hypersonic speeds, like I said, with about 150 pounds of payload. We can use different experiments on it. So those experiments can be control systems, can be thermal protection systems, can be actuator tests, navigation, flight navigation, autonomous flight termination, you know, all the different technologies that the industry is interested in developing. They could be on the outside of the vehicle at different locations. Leading edge materials, for example, is one that is of interest to the community. Or it could be inside the payload fairing, like a sensor or some type of telemetry or communication system could be inside the nose cone. We're designing them to cost about $5 million or so per attempt, per launch. They are expendable. The X-60As are expendable. And they're designed to be launched off of a Gulfstream business jet, underneath the Gulfstream business jet. I mentioned that this is about 3,000 pounds or so, and about 20 feet long is a general scale. I'll show you some people working on it here in a sec, so you'll get a sense of scale. So this is our first one. This is where we're starting, X-60A. We've been sponsored by the Air Force Research Laboratory out of Wright-Patterson Air Force Base in Ohio for the last few years, and they're our primary user and customer for the X-60A. Scaling to the X-60B model, I mentioned that that is a target variation, and so we're pursuing that for helping the defense industry develop countermeasures against hypersonic attack systems. So they need a very low cost target. So the X-60Bs are designed to be shot down. They're designed to go fast, be maneuverable, come in fast and hot to a defensive location, and let the team that are developing defensive capabilities try to shoot them down. And we can launch more than one at the same time. So we can simulate an attack, and it's basically a target variation of what we're trying to do. It is also liquid and single engine, but more maneuverable and a bit faster than the previous version. Not designed to be a test bed. It's designed to be a target, low cost. The bigger one, the C, is, I showed you a prior picture of that one too, flying with a different nose cone. So this one is a multi-engine one that we're just about to start work on. I think in a couple of months, we're going to get kicked off on that one with our sponsor. And it also is a liquid system, but is designed to fly bigger payloads. And in particular, I don't have it in front of me here, but in particular, the scramjet types, ramjet scramjet types of inlet systems, and is what that's designed to carry, not on this picture, but on the prior one. And then finally, there's this one. This is kind of the sexy one. This we call Go Next. It's our vision vehicle. At this point, it's nothing but a preliminary design. We've got trajectory information and aerodynamics and propulsion for it. But we think of this guy as being the ultimate Federal Express, or the ultimate UPS. So we can travel with him. We can reach speeds up to about Mach 15, and we can travel across the Atlantic Ocean in about an hour. It's designed to take off horizontally and land horizontally, autonomous. So there's nobody on board. It's just payload. So it's a UAV, and it uses combined cycle propulsion, which mixes rockets with air breathers with rockets again at the end. And so if you're familiar with that combined cycle propulsion, this would be an ejector, what's called an ejector ramjet solution, and it flies a periodic trajectory. So it's kind of a Silbervogel type of solution from 50 years ago, where they skip, bounce across the atmosphere to extend their range and maximize lift to drag ratio. So again, for fast cargo delivery, very fast cargo delivery in an hour or so across the Atlantic. So that's our vision concept. Again, this one is really more advanced design. This is a concept. Okay, so I've got some pictures to go through here for where we stand on the X-60A. So again, that's the small one. That's the current one. We've been after it for a couple of years. These are some pictures in our shop of Caleb. Doesn't look super happy right there, but Caleb is in charge of our avionics team. We've got 5 teams that support this, 5 teams of engineers. One is propulsion, one is structures, and structures also has thermal protection system as part of it. And then I've got avionics, embedded systems, and embedded system, well, I should say avionics are typically electrical engineers, and embedded systems are typically computer engineers, but there can be some aerospace or mechanical engineers mixed in that one as well. And then finally, there are systems engineers, and I'm really a fan of aerospace engineers as systems engineers on our team. I think aerospace engineers make great systems engineers. And so those are the 5 teams of engineers that support that. So together we've got probably 30 or 40 people that support this project. Picture in the top middle is us doing a captive carry on a NASA aircraft over in California a few years ago, where we were evaluating the clearance envelopes, ground clearance envelopes. You might be interested to know that the FAA requires you to have sufficient ground clearance under an airplane as if the struts are collapsed and the tires are blown. And with those cases, we have about an inch or so, in very worst case, between the bottom of our rocket, about right here, and the ground. And so we did a lot of envelope clearing. We're worried about exciting, for those of you who are doing anything in aeroelasticity, we're worried about exciting structural modes on the aircraft as we fly, because this aircraft, that's a C-20, but the one in the lower left is a G-3. They're about the same. They're not designed to have that big a store hanging underneath their bellies. And so exciting the high tail or exciting the wing modes is something we worry about. Next slide over, you see an inert test article, which is a drop test article that we have built for the current nose cone. You can see the shape is slightly different. Wings are slightly different, but this is the current design. there on the top left. That's an inert test article. This picture was taken at Wright-Patterson Air Force Base. That's not our facility. Our facility is the one on the left. Partner of Flying Under a Jet here is a company out of New York. We've done a number of wind tunnel experience. Somebody, Brian, were you talking before about getting in the wind tunnel? Yep, that's something we do too. So we did a lot of supersonic tests as well as subsonic separation tests between the aircraft and the rocket to make sure that it would separate cleanly. You do that with 2 stings at the same time, and you can move them apart in the wind tunnel at different angles of attack and side slip angles and different rates of separation. This one, of course, in the center of the Schlerin photograph is a supersonic case that we did at Wright-Patterson's wind tunnel in Ohio. And we did an entire campaign on that. That was used to support the computational fluid dynamics work, the CFD work that we did. So we built up a database in CFD, and then we went and ran about 150 cases or so in the wind tunnel. And then we validated that data set. I'm going to show you a video of what we did down in Florida the last couple of times, so you'll see that, but those are ground tests of the propulsion test article. And here's Megan working on some of the plumbing and regulation for the ground support equipment. I'll show you a video here, but Carissa, you had mentioned seeing the other video. I'll show you that and say, but that's the hot fire test that we did. We call that a hot fire test. So that's full liquid oxygen and jet fuel for about a minute and a half. The real burn is about 2 minutes. So single engine. And that's a test we completed a little more than a year ago in Florida. This is what the test crew looks like after about 2 weeks. So people are all smiling for this camera shot at this point, but before that they were grumbling like, I got to get out of here. This is the mosquitoes are killing me. But they deployed down to conduct that test and then came back home to Atlanta, after we were done. Couple pictures around the shop. Now you're going to start to see more relevant pictures or more recent pictures. People have masks on. COVID has been a bit tough for us. We have tried to stay open as a essential business here, and for the most part, we've been able to do that. We've shut down a couple of times. In certain cases, we've shut down for a week or two, come back to work, shut down for a week or two when there might have been 1 or 2 cases. So we've had a couple of positive cases, but we've been able to power through them. We have rules in place that have masks and sanitizing stations, and we do extra good cleaning in the evenings to clean surfaces with disinfectant and such. So we've been able to stay open, but I tell you, it slowed us down. It slowed down our suppliers. It slowed down the parts. It's harder to get things in an engineering environment when the supply chain is also affected. I'm just getting some of the parts that you see here in the aft end of the vehicle have taken longer than you might think. So all the solenoids and actuators that you see in the back end, a lot of the machine parts that we've outsourced have taken longer than expected. You can see some graphite epoxy thrust structure struts here in the picture, if you can see my mouse. This thing with saran wrap, you can kind of see it there. That's a composite overwrapped pressure vessel. So it's essentially a big beach ball that we fill with helium. The reason it has saran wrap on it right now is we're trying to prevent any kind of humidity or water damage on it. Of course, it would not fly with that, but that's just how we store it here in Atlanta to try to minimize the amount of water that can get into the resin. So that's what that is. Tank set is mostly aluminum. You can see on this one, I've got another picture later, but on this one, we've got our cryogenic foam up front. That's where the liquid oxygen is. We put foam on it to prevent it from icing, to provide insulation between the cryogenic oxygen and the air. The real vehicle will also have a thermal protection system designed to protect it from the heat of hypersonic flight as well. So there's a cold side problem and a hot side problem. Recent picture here of a couple of the guys in our facility doing some tube installation on the raceway of the vehicle. You can see they're in masks and well, mostly gloves. So that's kind of how it works. We don't have a lot of people around the rocket at the same time right now. So we're trying to stay as safe as we can. Construction is aluminum, as I mentioned, on the primary propellant tanks. The liquid oxygen is in the front, up there where Andre is, and the jet fuel or the hydrocarbon fuel is in the back. The engine, you're looking kind of right down here where my mouse is, of where the engine goes. And I showed you an engine in the prior picture. So it will be installed on that gimbal mount in the back. Skill sets here, I'll talk about them a little bit more later, but just to introduce you, structures has a huge role to play in designing aluminum pieces, getting them machined or causing them to be machined by our suppliers, doing a lot of work on ANSYS, finite element analysis, vibrational structural dynamic analysis. There's some thermal analysis required because I mentioned the very cold and hot nature of hypersonic flight, cold being the oxidizer, hot being aerodynamics. So yeah, structures has a huge role to play. Controls has a huge role to play. You can see all kinds of wires and actuators and all over the back end. And this is before we even put the wings on. So it gets worse. Thermal protection system, you can see the cryogenics here too. This is also in our shop. So this is a sister of the inert test article. So this one, you can see the actual rivets on it, composite nose cone, metallic structure. This guy is designed to be dropped into the ocean and just used as a separation test article. And it's full scale, full weight. It's loaded with steel plates to be used as ballast in lieu of the liquid oxygen. The liquid oxygen is actually pretty dense and pretty heavy. So to replace it with something, we have these steel plates inside of this guy. And it's balanced so that the center of gravity is in the right place. And it's also balanced so that it's distributed so that the mass moments of inertia, the IXX, IYY, IZZ are all accurate for the fueled version of this, fully fueled. And so this one mimics the size, mass, outer mold line, aerodynamic characteristics of the full vehicle. You can't really see the details in this one, but along the top here, once we put the cover on, there are two lugs that hang from the aircraft and they retract when we release the rocket from the aircraft. And there are a couple of quick disconnects, one for electronics and the other for top off helium. And so that are both quickly released when we separate from the aircraft. And that one's not fully assembled, but that's the kind of way we mate to the different aircraft. Again, this is the A model. Okay, so this is kind of the shop work. Let me show you what it looks like in the office. These are our typical workers. They have very short arms. This is Halloween, seriously. But this is what it looks like in the office. And we work at workstations and computers in an open collaborative environment. Each engineer, these two folks, one is Mira and one is Orion. Each of them are structural engineers. So they have, Mira, I think, is an aerospace engineer and Orion is a mechanical engineer. So they spend a lot of their time on CAD. Like I said, ANSYS, we use Solid Edge as well as SolidWorks here for CAD. And then I've got propulsion folks and avionics folks that work in this kind of environment. This is that office that I showed you that's over in Doraville. This is not the one I'm sitting in right now. Okay, we have made a couple of videos, and I know some of you might have seen them before, but I'm going to try to play them for you. That kind of chronicle what we're up to. We're relatively young folks. I mean, not me, but the people who work here, relatively young folks. And so this idea of telling an episodic story of our journey is kind of fun for us. Within the SpaceWorks group of companies, we have SpaceWorks Studios that does these kind of things for us. And so I'm going to drop out of here real quick and go over to my browser. Yeah, good point. Let's see, share, and then, wrong thing, here we go. Okay, Brian, can you see that browser again?
Yeah, yeah, it's perfect.
All right, so we've got a YouTube channel if you want to subscribe to it or kind of check it out for both Generation Orbit, that's this one, and then I've got one for SpaceWorks as well. So they've got a couple of fun videos that we've done, but we call this this little episodic Hypersonic Dreams, and there are 2 episodes. I'm going to play them in first and second order so you can get a feel for what we do and ask questions if you'd like at the end, but let me start it.
Hypersonics is changing the way we think and pushing the boundaries for technology in aerospace. But evolving technology is only half of the equation. Transforming these dreams into a reality demands expertise, tenacity, and innovation. That's where we come in. We are Generation Orbit. We are building a test platform for experimental research at hypersonic speeds. Our incredible team just reached a major milestone. We fired a vehicle's engine for the first time. Under the sponsorship of the Air Force Research Laboratory and with our great partners, we are racing to make hypersonic flight a reality. In the coming year, our vehicle will begin its mission, bringing with it the future of hypersonic flight, the X-60A.
All right, so that's the first one. So the first episode we did, and I'll show you the second one in just a second, but I do want to tell you that the aircraft that, the NASA aircraft that it shows banking, that was a simulated maneuver. So our release maneuver is like a zoom climb maneuver. So as we're flying along horizontally at about, subsonic, maybe Mach 0.8 or so, at 35,000 feet, we dive for a little bit and then we climb up to as steep as we can get that airplane, which is a flight path angle of, 35 degrees if we can get it, 33 degrees maybe. So pretty nice gamma flight path angle. And then we would release from there. The the rocket typically falls for about 4 seconds before it ignites. And in that time, the airplane banks hard over and recovers to the side while the rocket stays on track and then lights. So you saw the pilot in that case on the maneuver practicing his departure, but of course in that case the rocket was still attached. In reality, the rocket would be released and then he would depart after that. So we did a number of those zoom climbs to test that we thought that would that maneuver would generate sufficient clearance before the rocket is ignited. We think we can be vertical and horizontal, so total separation of maybe 4,000 or 5,000 feet before the rocket has to ignite. So that's what you were seeing. All right, let me play the second one and then I can talk about that one.
Our team is made of dreamers, believers, and innovators. Our journey has been filled with incredible challenges that have pushed us to the limits. Each step forward has brought the X-60A closer to achieving our hypersonic dream. Our progress is critical, not just for us, but for the nation and for the future of hypersonic flight. Faced with difficult programmatic and technical challenges, our small team has shown great resilience and perseverance. Over the past year, we have improved our overall design, undergone wind tunnel testing, constructed flight weight hardware, and performed full duration propulsion tests. With the support of the Air Force Research Laboratory and with our dedicated partners, we continue to break down the barriers to hypersonic flight. First flight is just around the corner, and we are excited. We are anxious, but most importantly, we are united in making our dream a reality. We are Generation Orbit, and this is the X60A.
Okay, am I back to the PowerPoint presentation? Can you see it?
Yeah.
Okay. All right. So things you saw in the second episode, some of them looked a little bit familiar, but they were different. In the hot fire test, we did throttling. So we're able to throttle down the engine and bring it back up. So that was one of the tests we did. We did gimbaling. I don't know if you saw that happen, but we gimbaled the engine up and down to watch it move. In that video also, there were some cold flow testing sequences. We did those in Atlanta. The hot fire test was done in Jacksonville, Florida, at a old Navy base there. But the cold flow test was done basically in our back parking lot. Interesting side story there. So we had used, you saw the white vapor coming out of the back of the cold flow test. That was primarily to test that the valving worked properly, the pressurization worked properly. We used an inert liquid. We used liquid argon as a surrogate for liquid oxygen. So we're trying to prevent, fires or combustion or anything. So that was liquid argon. It makes a big white cloud after it's done. But we had a number of spectators that came out on that particular test from the neighboring companies and buildings around us saying, you guys are dumping rocket fuel out all over out over the grounds, all over the parking lot. We're like, well, not really. This is liquid argon. And they were like, oh, liquid argon, that's terrible. And we tried to say, there's argon in the atmosphere already, and it's inert. But you see something like that, and if you're sort of a lay person, you think like, oh, whatever that is bad, because it just made a big white cloud of something, and like, you're going to kill all the grass or kill all of us. And so we always are having to educate people. We're the only aerospace company in that facility, so we get to do things like that. All right, let me move on here, and then I'm about to wrap up. So you saw that one. So let me kind of talk to you all as students a little bit and give you some thoughts or some advice. If this is a field that interests you, if you are interested in hypersonic flight, that is flight at or faster than Mach 5, just some things to think about. So most everyone I've met this evening is an undergraduate, so I would encourage you to go out and get some experience. Internships are a great thing. Co-ops are a great thing. If you can get experience while you're an undergraduate, I think you'll separate yourself from a stack of resumes. And I've got like a stack of resumes. Just for example, this is my stack of resumes. People with experience kind of stand out a little bit. Now, it's easier said than done. You'll have to be persistent to get an internship. I think most companies would be looking for you to probably be either a rising junior or maybe a rising senior. That's the kind of skill set they're looking to employ. If you are lucky enough to get an internship at NASA or a DoD lab, I think you can probably get that as a little bit younger person, maybe somebody that's even a rising sophomore. 1 or 2 chances to get an internship, I think, will help you in your future applications, as well as give you the experience to know whether you even like this field or not after you try it out for the summer. Most internships are paid. I don't want to promise any kind of prices here, but they're $15 to $20 an hour, something like that, maybe. It can be in the summer or during the academic year. Now, the caveat I'm going to put on this is that COVID has made it difficult. I get a lot of applicants at our companies that want to work on site, obviously, and working remotely or trying to be an intern from your apartment or from your dorm room is kind of crappy. And it's not all companies are taking interns during the COVID experience, but hopefully we'll be past that pretty soon, right? As an undergraduate, focus on the things that you can, skill sets you can gain that would help you in the area of hypersonics. So I've mentioned aerospace engineering before. You're all aerospace engineers. So aerodynamics is what we do well. It's what distinguishes, I think, aerospace engineers from any other kind of engineer. So subsonic, supersonic, or even hypersonic aerodynamics, if you can get any computational work, even if it's method of characteristics or 2D kind of computer modeling, those are the kind of skill sets you'd like to have on your resume as you apply to work in a hypersonic field. Controls and flight mechanics, or GN&C. That is an area of specialty that if you like that kind of thing, Brian, you mentioned you were taking that class or taking a class like that at State. The control of a vehicle flying at Mach 5 is very difficult. They tend to go through a wide aerodynamic flight range. Their centers of pressure move backwards. Their centers of gravity, particularly for these guys, are already back. It creates stability problems, and being able to keep the vehicle flying in a straight line, pointing in front first is difficult. So if you like GN&C, if you like modeling things in MATLAB and Simulink, you like feedback control systems, you can talk Euler angles and quaternions, that's good to specialize in. High-speed propulsion, and even though what I showed you this evening was mostly rocketry, the industry in hypersonics is heavily dominated by dual mode scramjets, ramjet, scramjet propulsion, so supersonic combustion ramjets. And so that kind of skill set, high speed air breathing propulsion, if you're interested in that, see what you can do. There used to be a propulsion class at State, I don't know if there still is, that touched on high speed propulsion. So I hope that's still there, but in any case, that's a good thing. Is it?
Yep.
Good. Are you in it?
Last semester.
Okay. Is that Dr. Edwards?
No, this time it was Dr. Granlund,
Okay.
but still good.
Edwards probably does the first one here on this list. That's probably his thing. I
Yes.
don't know if he only does it for graduate students, but he'd be the guy. And then aerothermodynamics, and particularly coming from NC State, there was a great history. I don't know if it's still there, but there was a great history of professors that specialized in aerothermodynamics, aero heating at high-speed flight. Dr. Hassan did, Dr. Desjardins did, and I don't know if that's still there or not, but it used to be a school that was really kind of known for that area. Worked closely with NASA Langley. So I don't know if you get aero heating much anymore, but if you did, that'd be a great thing to take an elective in or something. Join LinkedIn. LinkedIn is, in my opinion, is becoming the professional default network to be a part of. I know you guys are students, young people, you're probably all on TikTok or Instagram or Snapchat or whatever, but you know, professionals are not on that. Professionals are on LinkedIn. You can also kind of clean up your profile a little bit on LinkedIn and make yourself look sort of professional, and don't have a picture of you smashing a beer can on your head and you know, at some kind of rally against the evils of the Department of Defense. Take all that off and be very professional on LinkedIn and start to connect with some folks, join some groups. And when people apply to work here, either as interns or as full-time professionals, I'll often go to their LinkedIn page just to see what they put on there and what kind of things they like. And I'm looking for them to show an interest. I'm looking for them to be connected to a couple of things I'm connected to. So I would encourage you to do that and do it in a professional way. What about graduate school? I'm happy to talk about this further. My usual position is a master's degree in aerospace engineering will separate you from most of the folks in aerospace engineering. And so it's a good thing to have. It's not required by no means. People are quite successful without it, but I would encourage you to think about it. I think it does separate you and give you an advantage. Starting salary for someone with a master's degree is higher than a bachelor's degree by, you know, maybe $8,000 or $9,000 a year, and then that kind of helps you for the next year and the next year and the next year before the gap gets closed. So it doesn't quite pay itself back, but it does. There is something there. But also the type of work you get assigned as a master's person with a master's degree might be a little bit more satisfying for you intellectually. On the issue of whether or not you should get your bachelor's degree and then go to work and then have your employer pay for it, or at least provide you with time off so that you can pursue it. I put it down here, it depends. A lot of my younger folks are doing that. They're trying to get a class, take classes remotely. It takes a longer time, and it takes a certain sort of stick-to-itness if you're stretching your master's degree over like 3 years, because you're working during the day, or you're taking 1 or 2 classes at night, or whatever you're trying to do. It's tough. I think it depends on the person's individual situation as to whether or not they can go to grad school and sort of endure that period of low salary. If you have that flexibility, I'd probably say go ahead and just pull the Band-Aid off and get it done. But if you're in a position where no, I need an income for whatever reason, then a lot of organizations are at least providing you either some direct help or some indirect ways to encourage you to get a master's while you're working. Just takes a while. So I can talk more about that if you have questions. Where to work? You have kind of 3 major choices when you graduate from state with an aerospace engineering degree. You can go to industry, and there are a lot of choices. I'll talk about a couple of them. Government or academia or academic labs. They're all hiring. They all hire aerospace engineers. You kind of have to decide what kind of experience you want. I've listed them slightly out of the order here, but on the government side, everybody thinks of NASA, and NASA for hypersonics is still a great place. They do hypersonic work at NASA, NASA Glenn in Cleveland, NASA Langley in Hampton, Virginia. Some of the flight test places like NASA Armstrong out in California. NASA Ames, another leader in hypersonics. So the research centers, Ames, Glenn, Langley, and then I would say Armstrong would be a good one. The Department of Defense I've listed here generally, but specifically within that, Air Force, Army, and Navy are all involved in hypersonics, and they've been given different responsibilities. Air Force is more interested in air breathing. Army is more interested in boost glide, and Navy is more interested or is interested in fielding shipboard and submarine-based systems. So it kind of depends on what maybe the application is or what you would want specifically to look at. But these are the research labs at those different branches. Space Force, I don't know much about Space Force in the area of flight. We're barely beginning to touch Space Force on our satellite side of the business, out of Kirtland Air Force Base and out of Los Angeles Air Force Base, which does that mean that's a space base? I don't know what that's going to become. They're in transition. But Navy, Army, and Air Force. Missile Defense Agency, of course, what they do is in the title, missile defense. So some of those things from a defensive point of view are high speed, hypersonic on both ends, the incoming and outgoing. They're based in Huntsville, Alabama, primarily. FFRDCs, federally funded research and development centers. If you're not familiar with that, those are essentially nonprofit labs that are set up at the Department of Defense as civilian run or civilians kind of overseen. Sandia is run by Lockheed now. Lincoln Labs and Draper run by MIT. Georgia Tech Research Institute is run by Georgia Tech, and there's more of them, but you can end up at an FFRDC, and those are good jobs, kind of semi-government jobs. I would say at the government, you have a lot of stability. You have a lot of kind of decision-making power. They tend to be maybe a little slower, more bureaucratic to make decisions and get things done. But again, you get a lot of stability, and they have a great retirement plan. Over in industry, when I was going to school, we probably knew only about the first 4 names on this list. You know, everybody who wanted to work in industry either wanted to work at Lockheed, Raytheon, Northrop, or Boeing. You know, those are the major tier ones, and that's what we had, and that's what, you know, advertised. There were others. McDonnell Douglas, you know, got swept up in Boeing. General Dynamics got swept up in Lockheed. Martin did as well. So there's some consolidation, but the big primes are out there, and you know, Lockheed's got a lot of work in hypersonics, both at Skunk Works out at Edwards, or out at Palmdale, California, in the desert of east of Los Angeles there. And they've also got work in the Washington, D.C. area and in the Pennsylvania area. So they're kind of the big one. And they've got billions of dollars worth of work in hypersonics. Raytheon is located in Arizona, located in Tucson, Arizona, or throughout Arizona. So in the Southwest United States, kind of where a lot of their work is done, although they do have a manufacturing facility in Huntsville, Alabama. Northrop Grumman has facilities. They, of course, have acquired Orbital Sciences and ATK now. So they've got facilities in the Washington, D.C. area. They've got a big facility in Los Angeles. They've got facilities in Utah. And they're involved in hypersonics as well, mostly out of California. And then Boeing is also kind of everywhere, primarily for this kind of work, primarily in Los Angeles. Yeah, I think mostly Los Angeles, also St. Louis, possibly. There's still work at Boeing St. Louis, Missouri. But then, you know, now you guys live in a generation where you have this other whole long list. I put Generation Orbit in that list just because I'm giving the talk. But SpaceX, Ariane, Boom, Spike, you know, they're all doing high-speed point-to-point. You guys have probably been following SpaceX with the SN9, SN8, and then SN9 of the Starship, the big silver Starship that they're building, with interest in flying it halfway across the world, as well as to space. Ariane and Boom and Spike and Hermeus are all supersonic, hypersonic aircraft developers. Virgin Galactic has high-speed aircraft, commercial aircraft that they're helping put together, as well as the Spaceship Two, which is the space tourism vehicle that they're working on. You probably saw some of that. And then Stratolaunch, which is the company that originally was founded by Paul Allen, that has the super ginormous aircraft that has the 2 747 fuselages side by side. And then they're working on a hypersonic research test bed to drop between those two. So yeah, plenty of choices. Not all of those are startups anymore. I mean, frankly, SpaceX is, I have to take some kind of guess, but they've probably got 10,000 people now at SpaceX. And that's not a little company. It's a big company. And then Virgin Galactic's pretty big. Stratu and the rest are kind of small. And then academia, if you wanted to work in academia, which I did for a while, there are research engineer positions available. You don't have to be a professor. You can be a research engineer, which is essentially a staff member that works for a university. And in hypersonics, there's a new consortium. I don't think NC State's a member. I could be wrong. Led by Texas A&M, called UCAH. UCAH is a consortium academic hypersonics. I'm not sure what the A stands for. So there are opportunities to work at universities. They tend to be involved in more fundamental research, boundary layer problems or combustion problems, combustion mixing problems, you know, sort of, if you like theoretical, more computer modeling work, mathematical modeling, that might be a good choice for you. All right, and I want to end with this one caveat. I think this is my last slide, but the one thing is kind of bad news for a lot of the folks that are international. For the most part, if you want to work in hypersonics, you have to be either a US citizen or a permanent resident. That's a green card holder. You can't be on a visa, you can't be on a work visa, you can't be a citizen of a foreign country and work in hypersonics in this country. Very rare. And so I often field questions from folks that are maybe not, not from the United States, and say like, how do I get involved? It's hard for me to answer that. Almost everything I deal with, they limit it to U.S. citizenship or permanent resident. And that's because hypersonic technology is what's called ITAR controlled, ITAR, International Tariffs and Arms Regulations. It's essentially a government controlled data that does not want hypersonic information to get outside the country. Despite the fact that we're probably behind in this technology, that's still a thing. Okay. All right, that is all I have. So Brian, I've done a lot of talking. This has taken maybe longer than I expected, but I do tend to talk more like 50 minutes at a time. But I'm happy to answer questions. You guys are great to spend some time with me. And so if I can do anything to help you, let me know. So over to you.
Yeah, thank you. Thank you for taking some time to talk to us tonight. Really appreciate it. I'll stop the recording.